So, continuing with our review of hypothesis testing. Review problem number 3. A poll found that 35% of people say they drink a caffeinated beverage to combat midday drowsiness. A recent survey found that 19 out of 48 people stated that they drank a caffeinated beverage to combat midday drowsiness. At alpha equals 0.02, is the claim of the percentage found in the poll believable? So, the poll said that it was 35%. We did a little survey, asked 48 people. Out of those 48 people, there were 19 of them who said, yeah, I do that. I drink a caffeinated beverage to combat midday drowsiness. So we're going to test whether we can really believe that the percentage really is 35%, like the poll said. So that's the claim. It's a claim about a percentage. It's the claim that the percentage is 35%. So P equals 0.35. And so this would be a z-test for a proportion. Step 1, state the hypotheses and identify the claim. So the claim is that P equals 0.35. And because it has an equal sign in it, that would be the null hypothesis. So the alternative hypothesis would be that same equation, but turned into an inequality that P is not equal to 0.35. Now, your sample size is 48, so that's n. Out of those 48, the number of those who actually fit the category we're talking about here is 19. And then if you divide, 19 divided by 48 would come out to be about 0.396. So the poll said it was 35%. In this little survey, we got that it was 39.6% of the people we surveyed. Is that enough different from 35% that we can doubt that 35% is the correct overall percentage? So, depending on how you're doing this, if you're using the graphing calculator or the Excel spreadsheet, you would just put in the numbers 19 for X, 48 for N, and then 0.35, the number from the hypotheses, for your P number. If you're using that formula that I showed you and you're calculating this yourself, you'd need 48 for N, you need 0.35 for P, you would need 0.396 for P hat, and you would need a number for Q, and that would be 1 minus P. So 1 minus 0.35 would be 0.65. So however you come up with it, the test value Z turns out to be 0.67. And the P value turns out to be 0.5056. And that is greater than 0.02. We got a pretty big p-value. It was certainly greater than the level of significance, so we do not reject the null hypothesis in step 4. And what does that mean for step 5, where we summarize the results of our hypothesis test? There is not enough evidence to reject the claim. Remember, the claim was the null hypothesis. We just said not reject that null hypothesis. So that means not reject the claim. There is not enough evidence to reject the claim. Okay, number 4. A random sample of 12 winter days in Denver gave a sample mean pollution index of X bar 1 equals 43. So that would be the sample mean for those 12 days in Denver. Previous studies show that sigma 1 equals 21. So that's the standard deviation. For Englewood, a suburb of Denver, a random sample of 14 winter days gave a sample mean pollution index of X bar 2 equals 36. Previous studies show that sigma 2 equals 15. Assume the pollution index is normally distributed in both Englewood and Denver. Do these results indicate that the average pollution level in Englewood is different, either way, from that of Denver in the winter? Use alpha equals 0.01. So here we are comparing two different population means. the mean or average pollution index for Denver versus the mean or average pollution index for Englewood. Are they the same or are they different? The claim here is that they are different. That mu1, the mean for Denver, is not equal to mu2, the mean for Englewood. So that's the claim that we're testing. It's a claim about two different means, the means for two different populations. So this is a z-test for two means that we're going to be doing. So step one, the claim is that mu1 is not equal to mu2, and that would be the alternative hypothesis. It's about a difference. So the null hypothesis would have an equal sign in it. It would be that mu1 is equal to mu2. And we're given values in the problem for x bar 1 and 2, the sample means for Denver and Englewood. We're given values for sigma 1 and 2, the population standard deviations for Denver and Englewood. And we're given values for n 1 and 2, the sample size for the sample from Denver and the sample size for the sample from Englewood. So putting all of those numbers into either the formula or the graphing calculator or the Excel spreadsheet or whatever app or software or whatever thing you're using to do the calculations, you get a test value of 0.96. And then that means that the p-value is 0.3355. If you're not sure how to get these, or if you got something that was different from these and you can't figure out why yours is different and what you did different from me, ask me about it. Send me an email or get in touch with me somehow and ask me about it. But I'm not going to show you exactly how to get this because, again, there's different ways of doing it. Just pick the way that you're most comfortable with. And if you're still a little shaky on them, go back, watch the videos where we originally explained how to do this and where I actually went through an example of doing it using the various different methods, and focus on the one that looks easiest or best to you and work on that. So we got a p-value of 0.3355, and we are comparing that to our level of significance, 0.01. Now that p-value is way bigger than 0.01. So when the p-value is greater than alpha, that's when you say, when you get to step 4, do not reject the null hypothesis. So not means not. Not reject means there's not enough evidence. Not enough evidence for what? Well, here the claim was that these average pollution levels were different, that mu1 was not equal to mu2, and that, remember, was the alternative hypothesis. We were testing the alternative hypothesis. So not rejecting the null corresponds to not supporting that claim, which is the alternative. And not goes with not, so there is not sufficient evidence to support the claim that the pollution levels are different. They might be different. We don't know for sure. If we went back and got a bigger sample, we might be able to show that they're different, or we might not. But just from this, there's not enough evidence to be able to say that there's really any difference between the pollution levels of Denver and Englewood. Okay, let me end this video here and then come back and we'll look at the review problems dealing with correlation and regression. That's chapter 10.